In this lesson, we introduce the basic term and concept of cryptography. We show the mathematical formula and representation of crypto system and present you an encryption model or process and two basic encryption methods. Cryptography is a Greek word for secret writing. There are two confusing terms in cryptography. One is called cipher, the other is called code. Cipher is a character by character and bit by bit to bit kind of transformations. Sometimes we call it algorithm without regarding to the linguistic structure of the messages. The code, on the other hand, replacing one word with another word or symbol with special meaning. For example, in the World War II, the military hired Navajo coder to encrypt the messages using their native tongue. For example, here, Chatagai ne Chari actually refer to turtle's killer, and which is tank destroyer. And you can imagine how Japanese cryptanalysts had a hard time decode and figure out what is being said by this Navajo code talker. Often the code mechanism is using code boot instead, but here this Navajo code talker doesn't require any code book. It's their native tongue. The art of devising cipher is called cryptography. The art of breaking it is called cryptanalysis. The cryptography and cryptanalysis together is known as cryptology. A crypto system can be represented by mathematically by 5 tuples, E, D, M, K, C, where M is the messages, referred to a set of plain text. K, or key, is a set of key used in encryption and decryption. C is a set of ciphertexts, which is the result of the plain text after encryption. E is a set of in-cipher functions, produce the ciphertext, C. D is a set of deciphering function, taking the ciphertext, C, and the key, K, as the input, and then produce the original plain text, M. One of the famous cipher is Caesar cipher. It was so simple and so creative at the time, and actually it was not figured out by his enemy. Let's examine it using the above mathematical notation. The M is the old sequence of Roman letters. K is an integer between 0 and 25, all the uppercase or alphabet there. Including 0 and including the range 0 and 25. E is a set of all encryption function E sub k, where little k belong to big set key k. Given a plain text character M belong to a sequence of M, the E sub k of M will produce the value of M plus k modulo 26. It is another Roman letter. D is a set of all D sub k, where little k belong to the big k key, which is key again. Given a ciphertext character C, which belong to a sequence of C ciphertext, the D sub k of C is equal to 26 plus C minus k, and then operate on modulo 26. For example, k equals 3, a letter A will be encrypted by the encrypted function as letter D. A letter E will be decrypted by the decrypted function as letter B. You can verify yourself. For k equal 2, a word hello will be encrypted as JGNNQ. I will let you figure out what k value is for the encrypted hello to be KHOOR. Here we show an encryption model or the processing diagram using symmetric key cipher. Symmetric key cipher is a cipher that uses the same key both in encryption, sending side, encryption side, and the decryption side. We're using the same key to encrypt plaintext and decrypt the ciphertext received. The sender takes the plaintext, feed it into this encryption box with the key. The output of the box is a ciphertext, which is then sent along over the insecure channel. We assume that the ciphertext can be intercepted, copied silently, sometimes alter and send it along by the intruder to the receiver. The receiver receives the ciphertext, will feed into the decryption box with the same key, which is pre-agreed upon or sent through a separate channel. The output is hopefully is the same plaintext. The design of symmetric key cipher is to make it difficult for the intruder to figure out the plaintext. It should be rather fast to compute by the encryption box and decryption box. Hopefully, the receiver can detect any alterations of the message during the decryption process. There are two basic encryption methods, all building blocks: substitution cipher and transposition cipher. In substitution cipher, each letter or group of letters are replaced by another letters or another group of letters. It will preserve the order of the plaintext symbols, but disguise them individually. For example, the Caesar cipher is a simple substitution cipher. But there are more complicated ones, such as the monoalphabetic substitution cipher, where each letter is mapped to another unique letter in the alphabet. So there are 26 factorial combinations, close to 4 times 10 to the 26 possible key. So it's very protective. How one really to decipher here is the 3 famous words of Julius Caesar. And it's a mono substitution cipher, but how come it's only 4-letter words? They're all 4-letter words. Another basic class of cipher is called transposition cipher. Here we reordered the letter, but do not disguising them. We map them, or mapping them. The railfan cipher is a simpler version of this. For example, with the hello word, we will line them up in 2 rows, from left to right, up and down first, and fill the column first, and then left to right. After they line up, we then spell out the word in the row column first. For example, HLOOR, HLL followed by ELWRD will be sent out. It becomes a weird word, not recognizable.